So, hello everyone. My name is Kunal, and I am your mathematics tutor. And we are actually doing definite integration. And today is our the sixth lecture of definite integration. So, today is our the sixth lecture of definite. So, let me tell you first. हमने अब तक क्या क्या चीजें पढ़ी हैं. So, let me recap it. So, we already deal with some geometrical interpretation of definite, and then we deal with some property also. Then we deal with the Wallis formula, and then we deal with King's rule, Queen's rule, and then odd even property, and then we look how to implement those rules, and some manipulation based problem we see, right? We already seen this thing, manipulation based problem. So in today's class, we start with some problem and reach to some next property, which are also important in solving definite integrand. So let me start the today's lecture. So let's begin our today's lecture with some basic problem that we already uh, uh, with the actually problem based on the property which we already uh, read in our previous section or class. So let me take the first question of the day, which is something look like we have to integrate from minus pi to pi uh, cos of px minus sine of qx uh, whole square dx. Right. I hope you'll all understand is where P and Q belongs to any integer. So this is our problem. So if you look at here, our limit varies from minus a to a, where where a is equal to obviously pi. Okay. So we can apply here odd even rule. So I'm tell you like in previous section to first check that is it odd or even function. So first try to open this. So let me open here. So minus pi to pi. Okay. So there will be like minus pi to pi and then cos square px plus sine square qx minus 2 cos px sine qx, right? So we have there three terms. Now what you have to do, you have first check either the all function are either above written functions were odd or even. Because if the function is odd, that means fx is equal to minus of fx minus f of minus x. So we can write directly integration will be 0. So odd or even function, let me check it. So let me check the first this term. So what is on cos square px? So replace x by minus x. So what we get? Cos square p of minus x. So it also equal to cos square px. So no, our function is even function. Now let's check for the sine square qx. So there will be like sine square q of minus x. This is negative, but square make it positive. So it's also the even function. Now take the third term, which is like 2 cos px sine qx. So if you replace x by minus x, the cos px term will be positive, but sine qx term will be negative. So this equal to minus 2 cos px sine of qx. So this is an odd function. So we can write it into like minus pi to pi cos square px plus minus pi to pi sine square qx minus 2 cos px sine qx minus pi to pi. And when we integrate this whole function get 0 because this is odd function, right? So this get to 0. Now let me write here. So when we integrate this, so how to integrate this function? So apply the, either you can do one thing, like you can apply the uh, odd even rule, and then you need to convert it into Wallis formula, and then you get to the solution. So this is the thing that you can do. So now let me write here, okay, to clear your doubt. So you can go through that. You can even integrate it directly. So nothing to worry about. So let me begin with. Okay, so we can write this cos square px term as 1 plus cos 2p of x divided by 2 dx. And we can write the sine square term as minus pi to pi, that 1 minus cos 2px, cos 2qx by 2 dx. I hope you'll all understand this. So we can write like minus pi to pi, and this half from here we can write dx, plus minus pi to pi, and we can write here cos of 2px minus cos of 2qx, and then we have to take the half outside because this half and this half. And when we integrate this, what we get? Here we get 2p, 2 pi. Uh, Let me write here how I got this. Otherwise, okay. So what I'm trying to do here, x, and from minus pi to plus pi plus half of, and then you have to integrate this. So what we get? Sine 2px by 2p minus sine 2qx by 2q. And now on inserting limit, we get this term as 0, because sine pi is 0, sine minus pi is 0. So what we get the final answer as 2 pi plus 0, which is equal to 2 pi. So this is our final solution or answer. I hope these things are clear to you, right? So let me move on to the actually next problem. Actually, observe this as property. So let me write here, and this you have to remember, right? So let me write with some alag color. This is something like I have to integrate from 0 to pi by 2 log of sine x is equal to 0 to pi by 2 log of cos x. Obviously dx here is equal to minus pi by 2 ln 2. Actually, this is very standard formula. So you, and its integration is minus pi by 2 ln 2. So try to remember this. Okay. And I will show you the by a proof also. So, but at least you have to understand what I'm trying to say is, okay. So this is actually mostly I'm trying to say is key. When we integrate from 0 to pi by 2, and our given integrand is ln of sin x or ln of cos x. Okay, so the both integral value is same, and it is equal to minus pi by 2 of ln 2. Okay, so I hope you'll all understand this what I'm trying to say. So let's start it. Now, let me prove it so you can understand. So let me write its proof. So our I is equal to, we have to integrate from 0 to pi by 2, and our integrand is like ln of sin x and dx, and which is also equal to, so we can write it as I from 0 to pi by 2, because it's also equal to the ln of cos x. So just write it. Okay, and this is our equation number 1, this is our equation number 2. Add equation 1 and 2. When we add equation 1 and 2, what we actually get? We get 2I is equal to, we are integrating from 0 to pi by 2, ln of sin x, right? Ln of sin x and minus ln of cos x, right? I hope you'll all understand this, what I'm trying to say. I just actually add the both of these. So what we get? Ln of sin x plus ln of cos x. And we know that like ln of a plus ln of b is nothing but it is equal to ln of ab. Just a small property. So 2I is equal to this is the property that we are applying here. So we like 0 to pi by 2, and it's something look like ln sin x dot cos x. Now what I'm trying to do here, multiply and divide it by 2. Like I'm trying to say is ki, to create sin 2x. So ln sin 2x by 2, we can write it as like what I do here. There is my sin x into cos x, right? So I just do multiplication and division by 2. So this whole term creates sin 2x. So I just write it here, sin 2x by 2. So now what you have to do, uh, this is my form. Okay. Now, so our 2I is equal to, we can write from 0 to pi by 2, ln of sin 2x minus ln of 2. I hope this clear to you. I'm again using the same property of log, like ln of a by b is equal to ln of a minus ln of b. Okay, and now let's move on. Okay, so what I'm trying to do here, let 0 to pi by 2 ln sin 2x. This is our another type of integration. So let it as I or I1. Okay, and let 2x is equal to t. What you have to take? Just t, 2x is equal to t. So what I get from here, our I1 is equal to, here we see like variation in limit. So when x is 0, t is equal to also 0. And when x is pi by 2, t is equal to, let me write it in a good way. T is equal to pi. So our I value is something look like, I1 value something look like, we are integrating from 0 to pi and ln of sin t. And when we differentiate this, what we get, dx is equal to dt by 2. So it's something like dt 1 by 2. Right. And now what you have to do, applying Queen's here. What I am doing, just applying the Queen's rule here. Now what Queen said, integration of fx dx from 0 to 2a is equal to integration from 0 to a f of x plus f of 2a minus x dx. This is I have to do, right? So uh, let's write here 1 by 2. I am integrating from 0 to pi by 2 now. This is my ln of sin t. And then I replace my t to 2a, 2 pi minus t. So it's also equal to 2. So this get cancelled. So our I1 is equal to 0 to pi by 2 ln sin t. Are you getting my point? What I'm trying to say? And this is equal to I. If you look at here, what is our I actually? 0 to pi by 2 ln sin x dx, right? And here the same thing we get first in term of dt. And variable can be changed as according to our convenient. So what we get here, we actually somewhere written. Okay. So let this equation as equation third. So what we get from here, 2I is equal to, they're also equal to I and minus integration of ln2 from 0 to pi by 2. Ln2 dx from 0 to pi by 2. So what we get? Pi by 2 ln 2 minus, when we integrate this, and when we take this side, so we get I is equal to minus pi by 2 ln 2. I hope this thing's clear to you, right? Let me write it again, and then like I'm trying to again tell you how I prove this. So our given integral like 0 to pi by 2, I have to integrate from 0 to pi by 2 sin x. Ln sin x is our given function. So what I'm doing, and the thing says it's also equal to integration of 0 to pi by 2 log of cos x. And its value is like minus pi by 2 ln 2. It's actually standard value. We use this thing several times directly in a problem. So try to remember it. So how I prove this? So let's integration is equal to 0 to pi by 2 log of sin x dx. And since it is also equal to I, so we can also write it as I is equal to 0 to pi by 2 ln of cos x dx. So add the equation 1 and 2. Okay, so add the equation 1 and 2. So when we add equation 1 and 2, what we get? We are getting 2y is equal to, we are integrating from 0 to pi by 2 ln of sin x plus ln of cos x. And we just use the basic logarithmic property of ln a plus ln b is equal to ln of ab. And then we create here sine of 2x. Then we get our function converted into ln sine of 2x minus ln of 2. Then what I try to do, like we are assuming that our integrand, which is actually integrating from 0 to pi by 2 ln sine of 2x be as I1. This part as I1. And then substitute 2x is equal to t. And then we simply apply the Queen's rule. So what we get, our I1 is equal to I, right? And then we go through the equation third, which is here. Let me write here. From equation third, we get this point. I hope you'll all understand this. So let me go through the next problem. So our next problem is something look like. So try to remember it, because this is used as standard. Let me show you in next problem how we use this integration in a mid of problem, another problem, which is something look like this. So let me take here. Which is something look like we are integrating from 0 to pi ln 1 plus cos x and dx. So we have to integrate this. Okay. So how we proceed this problem? So any idea? So let me start with that. Actually, our standard form is saying I have to integrate from 0 to pi by 2 and ln of sin x or cos x. Sin x or cos x, whatever there, and dx. So its value is like minus pi by 2 ln 2. Right. But okay. So let's start. So we have to make its limit to be half. So there is one way which is we know already. This is Queen's rule. So apply Queen's rule here. So when we apply the Queen's rule here, what we get? We get from 0 to pi by 2 f of x and plus f of pi minus x. So we write ln 1 plus cos of pi minus x dx. So let me solve it here. So what we get? We are integrating from 0 to pi by 2 ln of 1 plus cos x. And what is this? This is actually minus cos x, right? Because we are in second quadrant, and second quadrant cos is negative. You can write ln 1 minus cos of x dx. So now what you have to do here? This is again in the form of ln a plus ln b. So what I'm trying to do, I'm just trying to do ln ab. So when we multiply this, we get 1 minus cos square x 0 to pi by 2, this is like 1 ln 1 minus cos square x, and we know 1 minus cos square x is like sin square x ln sin square x dx. And now we know that we can write this function as 2 ln sin x dx, because the power, whatever the power, we are using this concept like ln x to the power m is equal to m ln x. Okay, we are actually using this concept. I hope you'll all understand this. And now we know that the integration of this part as nothing but minus pi by 2 ln 2. So this get cancelled. So we get minus pi of ln 2. I hope you all understand this, what I'm trying to say. Right? So मैं बस यही बोलना चाह रहा था कि देखो, हमने इसे, ये जो हमारा स्टैंडर्ड रिजल्ट हमने जो प्रूव करा, how we actually implementing or using in problem, right? How we actually implementing or using this thing in problem. So this is the thing that we have to learn. I hope you'll all understand this, what I'm trying to say. So, okay, now, now let's move on to the next problem, which is something look like, let me write here. Okay, let me take that example also. So this is like question number, whatever it is, I don't remember. So we have to integrate where I is our, we're actually integrating from 0 to pi by 2, but this written in function form, f of sine 2x dot sine x and dx. So look, how to approach this problem is one thing. And after that, we read some property, right? After solving this question, we read some property, which is important for today's lecture. Okay, so this is the problem that we have to solve. Like our given integrand look like we are integrating from 0 to pi by 2, and there is a function which we don't know, but it's like sine of 2x written inside, and into sine x and 2 dx. So let me approach with King's rule here. Let's apply King's rule here. So what said the King's rule? Because listen, अगर क्वींस रूल लगाते हो तो क्वींस रूल में क्या होती है, लिमिट आधी हो जाती है, राइट? तो लिमिट आधी करने से यहाँ कुछ फायदा नहीं है, क्योंकि अगर कोई स्टैंडर्ड फॉर्म आता है तो अगर लाइक वालिस भी मुझे आगे लगाना हुआ तो वालिस भी 0 टू पाई बाई 2 पे ही लगती है, तो क्वींस लगाने का यहाँ कोई मतलब नहीं है, राइट? सो लेट्स अप्लाई किंग्स हियर. सो अप्लाइंग किंग्स रूल. So when we apply King's rule here, what we get? We just replace x by upper limit plus lower limit minus x. So here like pi by 2 minus x. So let me write the I. So it will be like 0 to pi by 2, and f of sine of 2, replace x by pi by 2 minus x. Okay, okay, and then sine of pi by 2 minus x and dx. So we can write this as we are integrating from 0 to pi by 2, and then this function repeat the things, which is equal to f of sine 2x, and this is like cos x dx, right? So let's this equation as equation number 1, this as equation number 2, and add the equation 1 and 2. So what we get actually when we add the equation 1 and equation 2, so what we get? So let me write here. So we are getting like 2i is equal to 2i is equal to, we are integrating from 0 to pi by 2, and f of sine 2x sine of x plus cos of x and then dx. And now apply the Queen's rule here, because King's rule अब तो कुछ हो ही नहीं रहा. So let's apply Queen's rule here. So when we apply the Queen's rule, it's something equal to 0 to pi by 4 f of x plus f of 2a minus x. So which is equal to f of pi by 2. Let me write here now. 2 into pi by 2 minus x. And they're written as like sine of pi by 2 minus x plus cos of pi by 2 minus. I hope you'll all understand this what I'm trying to say is right. And this is like dx. So when we solve this, what we get, we are getting actually here. Uh, Let me write here in a good way. So what we get just uh, 2 times because the both were same. So we are getting 0 to pi by 4 f of sine of 2x and sine of x plus sine plus cos of x. So this both get cancelled. So what we get I is equal to, we are integrating from 0 to pi by 4 f of sine 2x. And now look at here, if we multiplying and divide by root 2 here, like I'm trying to say, do root 2 by root 2 sine of x plus cos of, because we know that sine 45 is equal to sine 45 degree, right, is equal to cos of 45 degree is equal to 1 by root 2, right? We know this thing. So just I'm trying to make it and convert it into pi by 4 plus x. So we can write, we are integrating from 0 to pi by 4 root 2 f of sine 2x. And then we get here like sine of pi by 4. Uh, so let me write it here. We get sine of pi by 4 plus x dx. How I got? So I just use here 1 by root 2 sine x plus 1 by root 2 cos x. So we can write this is a form of like cos A sine B sine A cos B. So we can write it into like sine pi by 4 plus x. Now what you have to do, let me write it here in a good way. So our I is something equal to root 2. We are integrating from 0 to pi by 4 and f of sine 2x sine of pi by 4 plus x dx. Now what you do, just apply the King's rule again here. Therefore, this problem is based on combination of kings and queens rule. We are continuously doing kings, queens in pair. Sometimes we are applying kings as according to the step ask. जो भी स्टेप आस्क करे उसके अकॉर्डिंग हमें किंग्स लगाने के क्वींस लगानी है, वो अपन देख रहे हैं. So just try to analyze it, what I'm trying to do, right? So let me proceed in here. So like I have to apply the King's rule here. So let's apply King's rule. So just replace x by upper limit plus lower limit minus it, like pi by 4 minus x here. So what I get I is equal to root 2 0 to pi by 4. Just replace x by sine of 2 pi by 4 minus x, and then sine of pi by 4 plus pi by 4 minus x dx. So what I get here, I get I is equal to root 2. We are integrating from 0 to pi by 4, and this term is converted into f of cos x, f of cos 2x dot cos x dx. Right, this term is converted into f of 0 to pi by 4 f of cos 2x cos x dx. Right, and this is our nothing but I. This is our nothing but I. So what I have to do here, So this is our actually I is equal to, we're integrating from 0 to pi by 2 f of sine 2x dot sine x is equal to, we are integrating from 0 to pi by 4 root 2 f of cos 2x dot cos x dx. This is the result that we get from solving. See, this problem is actually based on how I like using the combination of kings and queens rule here. First, I apply the king's rule. First, observe the question. Like, what is question actually saying? I have to integrate, but there is a function of some sine 2x. I didn't know what is the function is. I didn't know what the function is, right? So what I'm trying to do here, let me write here the function like f of sine 2x, sine x dx. Now apply the kings and the king's rule here. So just replace x by upper limit plus lower limit minus of x. And then I applying the king's rule here. And then I add the equation 1 and equation 2. Then we get the equation 2 as like 2i is equal to some the result of king's rule. And then I apply a queen's rule because I have nothing to apply. Because देखो यहाँ पे odd even तो लगा नहीं सकते. Because odd even लगाने के लिए क्या चाहिए होती है? Our limit varies from -a to a. But यहाँ पे अपनी limit -a to a vary कर ही नहीं रही है. So we can't apply the odd even rule. So what I just do? I just apply the uh, Queen's rule here. So then I apply the Queen's rule. So I just replace x. We write fx as f of x plus f of 2a minus x in the form. And then we again apply the King's rule. Then we get the following standard result. I hope we'll all understand this. So let me try to uh, move on. So now starting some important property again here. So let me write here. Another important property. Important property. So let me make here a flow chart because it's not one property. There are several of property and I have to prove them all. Right? I am gonna prove you each and every single property. How is everything happening? Okay. So let me write first. So our first property would be look like when you are integrating. So let me write here a noted point. Let me use that. यहाँ पे note ये है कि let fx be a periodic function with period t. This you have to note that. Like जो भी हम यहाँ पे fx लिखेंगे वो एक periodic function होगी जिसकी period t है, right? So actually I think this is our the fourth property. So let me write here, it's part A. So when we are integrating a function from 0 to n t, where t is the period of the function, and n belongs to any integer, fx dx. So it is actually equal to n times of, we are integrating from 0 to t and f of x dx. This is our first property, okay? Let me write, so what I'm trying to do here is, we are actually doing nothing, just integrating our function fx, whose period is t from 0 as its lower limit and upper limit as n times of its period. So it's equal to this n comes in outside the limit and it's in form of product. So we write can n into, and we are just integrating the function in one period. So what I'm doing here, I'm just integrating the function in one period and multiply it by n times. Let me write the second property, which is something look like we are integrating from uh, mt to nt. There again, t is the period of the function, fx dx. So it is actually equal to n minus m 0 to t fx dx. And again, here m and n belongs to integer. Right, here m and n belongs to integer. So again, I'm trying to say here ki we are, what I'm doing here, I just subtract the number of times the period and just integrating in one period. What it represent? We are just integrating in one period and multiply it by n. Okay, let's move on to the third property, which is a property look like we are integrating a to a plus t fx dx, which is actually equal to we are integrating from 0 to t fx dx, where a can be any value. A can belongs to any integral value, and we are just doing what we are doing. Uh, Actually, ये सारी चीजें एग्जाम्पल से क्लियर हो जाएंगी. So first we have to go through its proof and then we look some example and learn how to implement this property. So it will be clear to you very soon. So don't worry much. Okay. So if in this property, what I'm trying to do, we are integrating our function fx from 0 to a value like say b, which is actually equal to our functions period and plus some value, which is also equal to some integral value. So its integral is also equal to, we are integrating the same function in one period. Like addition doesn't make any difference. Okay, so and now let's move on to the fourth property, which is something look like we are integrating from a to a plus nt fx dx. So this is actually equal to, we are integrating from 0 to nt fx dx, and when we are applying the property a, what we get, go through the property a. So what it's saying, it's also equal to n times of we are integrating in one period. I hope you understand this, what I'm trying to. Let's move on to the E problem. Okay, so our E something look like we are integrating it from A plus NT to B plus NT. So fx dx. So it's also equal to we are integrating from A to B and fx dx. Right. And let me write it here like n belongs to I. Okay. So this is our uh, things that we have to go through. Right. So let's move on to their proof. So proof for A part. So what is our A part? We have to prove क्या करनी है हमें? Okay, let me write with black color. Okay. So let's move on to the proof. So A, what we have to, okay. So what we have to, okay. So what we have to prove, actually we have to prove first, we are integrating from 0 to nt fx dx is equal to 0 to t for just one period and fx dx, right? T is the period and where n belongs to integer. So let's try to prove it. So first we move from the LHS and write like n is equal to 1, 2, 3, whatever we know, just write it here. So what we get, fx dx 0 to n t is equal to, we are actually integrating from 0 to t fx dx plus t to 2t fx dx. We can write it into this form now. Plus 2t to 3t fx dx because t is the period. So we just uh, go through one by one. So this there is like n minus 1t and t fx dx. I hope you'll all understand this what I'm trying to say. Now, what you do actually, this term, if you uh, substitute x is equal to x plus z plus t, where t is the period. So what we get? We get actually 0 to t f of z plus t dt dz. So it's also is equal to 0 to t f of z dz, which is also equal to 0. So t f of x dx, because variable uh, can be written in any form which doesn't affect our uh, product. So no harm to do this. And now for that, substitute x is equal to k plus 2t. So again we get 0 to t fk dk, which is also equal to 0 to t fx dx. So when we going through mathematical induction, so what we get actually is 0 to and t fx dx is equal to 0 to t fx dx plus 0 to t fx dx plus 0 to t fx dx n times. So it is actually equal to, let me write it here clearly so you can understand what I'm trying to say. Okay, there is one n times. So what we get here, n times of 0 to t fx dx, 0 to nt fx dx. So this is our valid proof. So what I'm trying to say, uh, I hope you'll all understand this. So let me tell you once again. So what I'm trying to do here is, I just, we can write our LHS, which is equal to 0 to, we are integrating our function fx from 0 to nt. So we can write like 0 to t, t to 2t, 2t to 3t, 3t to 4t. ऐसा कहाँ तक n minus 1t to nt. And then what we do, we just substituting our x as for t to 2t term, we are just substitute our x as z plus t. And from 2t to 3t, we are just substituting our x as k plus 2t. So follow like for n minus 1 for this, we are substituting our x is equal to something lambda plus n minus 1t. So we get the same result like 0 to t fx dx. Okay, so you have to go through it. Okay, so we okay, and then we look into it, and when we add this whole thing, so what we get actually this thing like 0 to t fx dx, 0 to t fx dx, and this going to n times, right? So we can write it as we are integrating from uh, 0 to nt fx dx from, which is actually equal to n times of 0 to t fx dx. I hope you'll all understand this, what I'm trying to say. Okay, so now there is a one thing that you have to uh, learn about. Uh, like these are the property are very sensitive. Why sensitive? Because you have to know the period of each and every single function. अगर period आपको पता नहीं है, then you can't apply this property, right? You have to aware with the period. And one more thing that you have to learn is nothing but how to implement this property. So let me take an example. हाँ, बाकियों का proof we see, but I think today we don't have time. So let's go through one example which based on our property one. So let's take it. So which based on this property. So our question look like we are integrating fractional part of x dx and from -5 to 0. Okay. And we know that if you look through the graph of fractional part of x, let me make it in a good way. Okay. This is our x, this is our y-axis. And so the fractional part of x graph is something look like this. This is our 1, this is our 1, this is our 0, comma 0. So this something look like our fractional part of x graph. This is 2 and this graph is followed. So our the period of the graph, period of function, fractional part of x is 1. Okay, so we are gonna apply this property here. So what I'm trying to do here is, if you look at through what, we can interchange the limit now. So just put it here and do -5 to 0, fractional part of x dx. And so here written as -5 times 1, fractional part of x dx, and there is 0. So we know that this is actually equal to -5 times, and there's the -1 already. We are integrating this from for one period, right? And we know that when our element varies from 0 to 1, it's actually look like x. So we get like 5 into, we are integrating it from 0 to 1 x dx. And when we integrate this, what we get? 1 x square by 2. So let's try to input the limit here. So we get 5 by 2. So you learn how to implement this into real problem, right? So try to understand what I'm trying to say is, like, right, what I'm trying to say, this is our property and how we implement it. So we first write the period of the function. So try to write the first period of the function, which is actually 1. We get by the graph, or we can do like f of x plus k is equal to fx. So try to find the k. Okay, so this is also the way to find the period. Hope you learn these all thing in your period chapter. I'm sorry, function chapter. So okay, so these things are we have to learn. So in next class, we prove we actually prove the left properties, and then learn how to implement those, and then we move on to next topic. Okay, I hope you'll all understand this, what I'm trying to say. So, okay. Uh, thank you. Thank you for today. That's all for today. Thank you very much.